This is sample problem LC.C40, and section LC is on linear combinations. And this practice problem is all about putting the solution to a system into vector form. We've already looked at how you can write the system in vector form, and this is how you can do it with the solution set. So first we got to solve the system, and that means taking the augmented matrix and putting it in reduced row echelon form. So first, the augmented matrix is 2, -4, 3, 0, 1, 6. Second row is 1, -2, -2, 14, -4, and 15. Third row is 1, -2, 1, 2, 1, -1, and the final row is -2, 4, 0, -12, 1, -7. Okay, and then when we put this into RF, this is what we get. So the reduced row echelon form is 1, -2, 0, 6, 0, 1. Row 2 is 0, 0, 1, -4, 0, 3. The third row is 0, 0, 0, 0, 1, -5, and the last row is all zeros. So that's the RF for it. So we've got pivot rows in column 1, 3, and 5. So that makes columns 2 and 4 are free variables. And here's how you sort of build the solution set using vectors. It's really quite nifty. So this is a 5 equation system, so that's what we start with. We start with basically what each equation is going to be. So it's x1, x2, x3, x4, x5. So that's our vertical vector, and that's going to give us our solution vector x, and this will basically be the solutions, is whatever these guys turn out to be. Well, what's that going to be equal to? Well, what I need to do is start with the solution column, because we want to build everything on the far side as if that's what these guys are all equal to. And you'll see one difficulty is there's only 4 values in the solution column, and in reality, there's 5 variables. So how do we build that solution column? Here's how it works. Because vectors or solutions for 2 and 4 are free, they get zeros in their column. So there's a 0 here and here, because in reality, there's no equation for vectors 2 and or for values 2 and 4. Those are our free variables, so they're equal to themselves. So there's no equation that tells us what they're equal to. It's just them being equal to themselves. So there's no number to add or subtract. And then we fill the remaining numbers in. So it's 1, 3, and -5. Now we can build the rest of the solution set. So I add on my free variables, and then I'll build the vectors for those. Again, my free variables are 2 and 4, so it's going to be x2 times a column vector, and this guy will take on real importance in our next lesson, and then x4, and that gets its own column vector, and then we'll be able to build the entire solution set out of this. Okay, the easiest ones are x2 and x4 themselves. I know that x2 is just equal to itself, so I need a 1 in this column and a 0 in the x4 column. And for x4, I need a 1 in this column here and a 0 here. So those are the easy ones, okay? For everything else, I'll use the equation. Over here, I know x1 is supposed to be 1 minus 6 x3 minus 6x4 plus 2x3. So all that happens is these guys change their signs but keep their columns. So this will be -6 and +2. So 2 and 6. The same thing will happen on 3. On 3, For for x3, again, x3 is going to be the answer minus 4 times, or when it gets to the other side, it'll be positive 4 times x4. So this gets a 0 in the x2 column and a 4 in the x4 column. And then finally, x5. And x5 was actually a fixed variable, so it wasn't a function of either x3 or x4. And so x5 is negative 5, and so it gets zeros for both. And there it is. This is the vector solution to the equation. And I could build it just by writing the individual equations. X1 equals 1 plus 2x2 plus 6x4. X2 equals 1. X3, X2 equals 1 times x2. So x2 just equals itself. X3 equals 3 plus 4x4. X4 also equals itself. And x5 equals negative 5. So x5 is fixed, 2 and 4 are free, and 1 and 3 are functions of 2 and 4. And there we go. There's the vector solution to this system of equations.